I welcome all of you on platform of YourPedia Education, and you are watching the 50 most important topic series, which is directed and made exclusively for your upcoming exam, that is Airport Authority of India exam. Now in this we are covering the most important 50 topics, and I am covering this for physics as of now, and this is the second video of that particular series. Don't miss it, because we will be covering the very important topic in this, from where probability of coming question in the exam is very high. Now in the first lecture, if you have not seen, you can refer that. Some lectures are related, but other lectures are independent also. There are some exclusive topic. This particular lecture is related to previous one, and I am taking the lectures as per the importance also. What you should do the first, because the most important part we are going to cover first. Now first lecture was electric flux. I discussed with you what is the meaning of electric flux. Electric field lines are already known to you in the electrostatic. Electric field lines can be, because of the charge, or otherwise there is an electric field existing already. So positive charge, negative charge, positive charge, the electric field lines come out of it, negative charge merge on these, that everything is part of electrostatic, and you will understand that. Similar to magnetic field lines, there are electric field lines also. Now electric flux means flux means something which is going out. Flux means not entering inside, it is going out. So electric flux means how many electric field lines are going out, coming out from particular surface area. We have area, and area, as you know, two-dimensional concept. Later on, electric flux is a concept which is related to three-dimensional body also. So roughly what we understand is that suppose I give you this as a surface, plane surface, and as you know, plane surface is a two-dimensional entity. Suppose I give you this as a plane surface. Now how many electric field lines are coming out of it? How many electric field lines are coming out of it? So that defines the electric flux. The formula of electric flux is nothing but E dot dA, and that is integration. So something like this. E is nothing but the electric field, and area dA, when you integrate, that is nothing but the area basically of that surface from which this is coming. Now we know area is a vector. We know that area is a vector, and suppose I give you some area like this, then how do we find what is the direction of this area? You need to draw a line perpendicular to this plane. So that means if this is the plane, you need to draw a line which is perpendicular to this plane. So this board is one area. If I put the pen like this, if somebody asks you, is board an area? Answer is yes, it has a length and it has a width. So board is an area. Area is a vector. It has magnitude and direction also. Magnitude is calculated for rectangle as length into width, and direction is just perpendicular to this plane is a direction. You put the pen perpendicular to this board, this is the area vector. So area is a vector, and that is perpendicular to the plane of that particular plane of that surface. So we have a surface area, and that plane of that perpendicular to that is a area vector. Now what last time we understood was, like suppose I give you the electric field E vector, and I give you area vector also. Now area vector can be in any direction, right? This can be perpendicular to the plane of that surface, and electric field also is a direction, and let us say angle between these two is theta, right? So what we understand is electric flux is E dot A, that's a dot product, and you know how dot product is to be open, EA cos theta. So that means that component of electric field which is along the direction of area, you can take the component of E along area, this becomes E cos theta. So total electric field lines which are coming out of a surface, and electric field lines coming out of the surface means you have to take in the direction of area vector. So that is called electric flux. That is understood. That is the last lecture. Now what is Gauss law? Last class we discussed about the Gauss law also. Let me give you one closed loop and I have kept a charge Q, positive charge Q inside this closed loop. So this I have given you closed spherical loop, let us say spherical shell or something. I have given you a spherical shell like this, and I want to know what will be the electric flux because of this charge. Now for symmetry, I assume that charge is symmetrically located. It has electric field lines all over. So because it is positive charge, electric field lines will be going in all the direction away from this particular charge. And I assume that it is symmetrically located at the center. Let us say O is the center and the radius is R. Now how to find out the electric flux because of this charge? First we take elemental strip. Let us say we take very small elemental area, not strip, elemental area. Let us say dA area. And we want to find out what is the electric flux coming from this elemental area. Can you tell me the direction of area? Yes, it is in the same direction because perpendicular to this is in the same direction, radially outward direction. So what is the small elemental flux coming from this is E dot dA. And if we want to find out total, then this is nothing but cyclic integral about this entire surface. Similarly, I can take many such elemental areas and I can sum up the effect of all this. In the electrostatic, we have discussed that electric field is 1 by, if I give you a charge Q, and if I want to find out because of charge Q, let us say this is the positive charge Q, and because of this charge Q I want to find out the electric field at this particular distance R from this, then Coulomb's law says 1 by 4 pi epsilon naught. Epsilon naught is nothing but permeability, right? So 1 by 4 pi epsilon naught Q by R square, and the direction is away from the charge Q. This formula we already know. Now you see one thing, the electric field everywhere is same, R everywhere is same because I have put the charge symmetrically. अभी कितना हो जाएगा ये? So if we calculate it, the phi is coming out to be E dot dA cyclic integral. What is the angle between E and dA? 0 degree, cos 0 is 1. So this becomes E into dA cyclic integral. E can be taken out, cyclic integral dA. Why E is taken out? अभी इसमें देखो सारे के सारे कांस्टेंट हैं एंड सब जगह E का वैल्यू बराबर है. मैंने इसको सिमेट्रिकली ले लिया. आई हैव टेकन इट सिमेट्रिकली, बाद में बताऊंगा. इवन इफ इट इज नॉट लोकेटेड एट द सेंटर, इलेक्ट्रिक फ्लक्स सेम रहेगा. सो ये आ जाएगा E इंटू 4 पाई आर स्क्वायर. अभी तुम इसको वैल्यू पुट करोगे, प्लीज पुट द वैल्यू ऑफ E 1 by 4 pi epsilon naught Q by R square 4 pi R square. If you multiply it, you get Q by epsilon naught. So this is the derivation of Gauss law. This particular thing is called Gauss law, and that is something which is very, very important. This is Q by epsilon naught, electric flux phi is equal to Q by epsilon naught. ये बहुत ही इंपॉर्टेंट लॉ है. दिस सेज दैट अगर किसी क्लोज स्पेस के अंदर, इफ देयर इज अ क्लोज स्पेस एंड इफ आई कीप अ चार्ज इन द क्लोज स्पेस, देन द टोटल इलेक्ट्रिक फ्लक्स बिकॉज ऑफ दैट चार्ज, पॉइंट चार्ज, इज Q by epsilon naught. गॉस लॉ के बाद में और भी वेरिएशंस हम देखेंगे. वी विल डिस्कस अबाउट दैट ऑल्सो. नाउ वन मोर वेरी इंपॉर्टेंट थिंग हियर इज दैट Gauss law does not depend upon shape and size of the closed space. Whatever closed space you have provided, it does not depend upon the shape and size of that closed space. What do I mean by that? I keep a charge inside a spherical shell. Whether it is a spherical shell, मैंने उसको एक spherical shell में रखा, या मैंने एक क्यूब के अंदर उसको रख दिया. Suppose I have kept it inside a cube of size A like this, or I have kept it inside a cylindrical shaped body. मैंने उसको एक सिलेंडर के अंदर रख दिया. Even if I kept anywhere, लेकिन अगर मैंने उसको क्लोज कंटेनर के अंदर रखा है, if I kept it inside the closed container, तो इलेक्ट्रिक फ्लक्स in each case will be Q by epsilon naught only. Phi will be Q by epsilon naught. तीनों केसेस में फाई का वैल्यू विल बी सेम. दैट मीन्स ये डिपेंड नहीं करता आपका शेप पे एंड साइज पे. व्हाट इज अनदर वे टू सी दिस? अनदर वे टू सी दिस इज, लेट अस से मैंने एक चार्ज Q को छोटे स्फेरिकल शेल में रखा, फिर मैंने बड़े स्फेरिकल शेल में रख दिया, या मैंने किसी और शेप में रख दिया. लेट मी मेक इट दिस साइड. मैंने एक चार्ज लिया, फिर मैंने क्या किया, मैंने उसको एक छोटे से क्यूब शेप में रख दिया. लेट अस से मैंने उसको एक क्यूबिकल शेप में रख दिया. अभी मैंने क्या किया, नाउ आई टेक अ स्फेरिकल शेल, और मैंने क्यूब को स्फेरिकल शेल में रख दिया. अभी मैंने क्या किया, मैंने एक सिलिंड्रिकल शेप लिया और मैंने स्फेरिकल शेल को उस सिलिंड्रिकल शेप के अंदर रख दिया. नाउ सी दिस केयरफुली. Whatever electric field lines are to come from this charge, whatever electric field lines, let us say 4 electric field lines are coming. I am giving example. Let us say 4 electric field lines are coming from this charge. My question to you is, how many lines are cutting the cube? 4. How many lines are cutting the spherical shell? 4. How many lines are cutting the cylinder? 4. That means electric flux does not depend upon size and shape of the container. Only thing you need to see is whether that charge is kept inside that particular container or not. That is very, very important. Now suppose I give you this kind of body. Now suppose I give you this shape and I keep charge Q1, charge Q2, charge Q3 inside the closed container. This is the 3-dimensional closed space. Can you tell me what will be the total flux? Yes. So total flux will be Q1 plus Q2 plus Q3 divided by epsilon naught. Yes, total charge you have to add. But as you know, charge can be positive, charge can be negative also. If the charge is negative, you have to use the negative thing also. Let me give you example. Suppose I give you charge Q and minus Q. Can you tell me what is the total flux, electric flux in this case? Because total charge inside is 0 and hence total flux in this case will also be 0. Now normally student get confused when I give them this shape and I keep a charge outside. अभी मैंने charge Q को outside पे रखा. Let us say I kept this charge outside, not inside but outside. Can you tell me what will be the total electric flux if I keep the charge outside? Now let us say this is the electric field lines going. This is the area, elemental area. This is also elemental area. Electric field lines की direction, electric field line की direction. So the electric field line which goes from this charge, let's say this is a positive charge, it cuts, it enters the space, it goes out of the space. What is the total electric flux? Now electric flux का definition what we know is E dot A, dot product. When you calculate E dot A, see this carefully. यहाँ पे direction of your area, if I take area with this color, direction of area and electric field is same. That means phi here will be E A cos 0. But in this case, area direction will be this, and hence phi here will be E A cos 180, and hence it is negative. So जब हम इसको ऐड करेंगे तो total electric flux हमारे पास जो आ जाएगा, that will be E A minus E A is equal to 0. So if I put the charge outside, electric flux means the electric field lines going out of the surface, not entering inside. Going out अगर positive लेना है तो entering inside is to be taken negative and electric flux will be 0. Now there is a very interesting phenomena which you should understand, which in terms of this you have to understand this entire thing. Suppose I give you a cylindrical shaped body and I keep a charge, let us say Q, inside this particular body, cylindrical body, and I keep a charge inside this body. Can you tell me what is electric flux? Electric flux in this case will be Q by epsilon naught. Good. अब मैंने क्या कर दिया, मैंने इस सिलेंडर को दो पार्ट में बांट दिया. I cut it in two parts now, and now this is my new diagram. This is the charge. चार्ज यहीं रहेगा, चार्ज को मैंने यहीं पे रखा, and this cylinder now, ये पहले L/2 था, this one also L/2, and this area was A. In this case also this area is A only, but this length is now L/2, and the charge is kept on the surface. यहाँ पे मैंने चार्ज रख दिया टॉप पे. Can you tell me what is the electric flux because of this charge through this cylinder? Electric flux because of this charge Q through this cylinder is Q by epsilon naught. Electric flux because of this charge Q through this cylinder, now this is a half part of that, will be how much? You know, there are two ways to see this. One is half this electric flux and other half is this. You understand? I can visualize this cylinder as made up of two parts, this half part, this half part, and let us say the charge is kept somewhere here. Charge हमने center पे रखा है, right? So whatever electric flux will go, you know, this is the electric flux. Electric flux is nothing but electric field lines, right? अभी total electric flux कितना है? Q by epsilon naught. तो इसमें से कितना जा रहा है? Q by 2 epsilon naught, और इसमें से कितना जा रहा है? Q by 2 epsilon naught. So suppose this question comes कि अगर मैं तुम्हें सिलेंडर के ऊपर, if I keep a charge on the cylinder and ask you what is electric flux now, electric field lines which are going to cross through this particular surface, through this, how much will be electric flux through this particular surface? That will be half of it. एक imaginary complete करो, make imaginary complete basically closed space, and then divide that into two parts and provide the answer for that. If you have understood this question, let me give you another question related to this. अगर तुम्हें समझ आ गया, I give you a cube, and inside the cube, I give you a cube, and inside the cube I give you a charge, let us say Q charge. Can you tell me what is electric flux through this cube? Q by epsilon naught. That is a Gaussian law. Q by epsilon naught, that is a Gauss law. एक क्यूब में चार्ज रखा है और उस चार्ज के थ्रू, उस चार्ज से कितना इलेक्ट्रिक फ्लक्स निकलेगा थ्रू दिस क्यूब, दैट इज Q by epsilon naught. Okay, done. Now next question is this. Same cube I give you same cube. As you know, shape and size is not important, but where you are located the charge, that is important. So मैंने अब चार्ज को यहाँ पे रख दिया. I give you the same cube, but चार्ज को यहाँ पे रख दिया. Now you have to find out the electric flux. Find the electric flux through the cube due to charge Q kept on the corner. मैंने कॉर्नर पे एक चार्ज रख दिया Q, and I want you to tell me what will be the electric flux actually through this cube. I told you that you have to imagine the hypothetically closed surface, closed symmetric surface. ऐसे कितने क्यूब को बना के मैं एक सिमेट्रिक सरफेस बना सकता हूँ? जैसे इन द प्रीवियस केस आई मेड अ सिमेट्रिक सिलेंडर, imagining this cylinder, and then the charge is inside that, and then I said total is this much, so आधा इधर चला गया, half goes this side. How many imaginary surfaces I can visualize? How many symmetric equal imaginary surfaces I can visualize so that it becomes the closed? Let me give you some diagram here. Maybe you can make some visualization. Can you visualize this little bit? Now one cube is given to us. Let me make it with some another color so that we don't get confused. With the blue color itself I make. This one is given to us. This one is given to us. Okay, and charge is here. This one is now 1, 2, 3 and 4 on the top. ये तो 4 क्यूब आपको नजर आ रहे हैं. You understand that? And 4 on the top. So this corner is shared by 8 cubes. This corner is shared by 8 similar cubes. Similar is very important. That means total electric flux through all this now will be electric flux will be Q by epsilon naught, and this electric flux Q by epsilon naught is shared by 8 cubes. And what is the question? Question is only to find out the electric flux through one cube. So how much will be the electric flux through one cube? I'll say the phi, that is a question actually. So phi will be equal to Q by 8 epsilon naught. Very very simple question and logical question, and you know thought provoking also. आपको सोचना पड़ेगा, विजुलाइज करना पड़ेगा, उसके बाद आप ये बता सकते हैं कि उसमें से कितना फ्लक्स निकलेगा. वेरी वेरी इंपॉर्टेंट टॉपिक फॉर एयरपोर्ट अथॉरिटी ऑफ इंडिया ऑल्सो, एंड फिजिक्स का इंपॉर्टेंट टॉपिक है ये. सो आई एम श्योर यू विल अंडरस्टैंड दिस पर्टिकुलर कंसेप्ट. इफ यू हैव डन दिस, आई एम गोइंग टू आस्क यू सिमिलर अनदर क्वेश्चन. आई एम गिविंग यू अ सेमी स्फेरिकल शेप्ड बॉडी, और मैंने इसको यहाँ पे चार्ज रख दिया. आई केप्ट अ चार्ज हियर, सेमी स्फेरिकल, यू नो इट मे बी ऑफ रेडियस, सम रेडियस इज r, और मैंने चार्ज को ऐसे सेमी स्फेरिकल सरफेस में रख दिया. हाउ यू आर गोइंग टू सॉल्व इट? सो से सर आई एम गोइंग टू मेक अ हाइपोथेटिकल सरफेस. नाउ मैं एक हाइपोथेटिकल सरफेस क्रिएट करता हूं, एंड वो भी सेमी स्फेरिकल रहेगा ऐसा. नाउ चार्ज इज केप्ट at the center, let us say this is the charge. Now what is the total electric flux? Total electric flux is Q by epsilon naught. तो इसमें से कितना आएगा? इसमें से आ जाएगा Q by 2 epsilon naught. This is how you need to visualize it. तो इसमें से कितना आएगा? चार्ज को मैंने सरफेस पर रख दिया, तो इसको कवर कर दो. कवर किया तो Q by epsilon naught, लेकिन सिमेट्रिक बॉडी के साथ इसको कवर करना है. That is something which is very very important. So you are to cover it with the symmetric body. Got it? Now let me give you one formula which you need to remember for your airport authority of India exam. Derivation भी है उसका, but you need to remember this. Let me give you this shape. I am giving you a conical shaped body. Cone you know, right? I am giving you a conical shaped body, and charge Q is kept inside that. कॉनिकल बॉडी और चार्ज मैंने उसके अंदर रख दिया, राइट? व्हाट विल बी द इलेक्ट्रिक फ्लक्स? एनी आइडिया? व्हाट विल बी द इलेक्ट्रिक फ्लक्स? Q by epsilon naught. Everybody knows that is Q by epsilon naught. अच्छा, अगर मैं इस चार्ज को, आई गिव यू अनदर डायग्राम नाउ, अगर मैं इस चार्ज को इसके इस सरफेस पर रख दूं, then what will the electric flux through this cone now? Again question is very simple. अभी हमने किया, just imagine another cone on the top, so Q by 2 epsilon naught. Right? If it is a closed body, then this is how it is going to be. The third question comes is this: what if I keep this charge at the vertex? सपोज मैं इस चार्ज को यहां पे रख दूं, मैंने Q चार्ज को वर्टेक्स पे रख दिया, यहां पे रख दिया. अब हम कितना इलेक्ट्रिक फ्लक्स निकाल सकते हैं थ्रू दिस पर्टिकुलर सरफेस नाउ, राइट? सो हाउ मच इलेक्ट्रिक फ्लक्स आई कैन कैलकुलेट थ्रू दिस नाउ, राइट? सो बिकॉज ऑफ दिस चार्ज, व्हाट विल बी द इलेक्ट्रिक फ्लक्स? दिस इज एट द वर्टेक्स नाउ, and there is a formula. We can derive that formula also. There is a formula, और उसका derivation भी कर सकते हैं, लेकिन आप उसको ऐसे ही याद रखें. Formula I am giving you, and that formula is very important. So question is, what is the electric flux find the electric flux through cone for Q at vertex. अगर मैं वर्टेक्स पे Q को रख दूं, चार्ज को अगर मैं इसके वर्टेक्स पे रख दूं तो कितना इलेक्ट्रिक फ्लक्स आएगा, एंड दिस इज द फॉर्मूला. Phi is coming out to be Q by 2 epsilon naught 1 minus cos theta. 1 minus cos theta. That is the value which is coming. This is the value which is coming. And obviously this particular case is a special case of this, because the moment charge is taken here, this line becomes this and theta becomes 90 degree. So this becomes the formula for the conical surface. Now let me give you this question here. Let me see whether you can find this question or not. I am giving you this cylindrical shaped body and I have kept a charge Q at the center. Let us say this entire length is 2r and let us say the radius is r of this cylindrical body. Charge is kept at the center. Can you tell electric flux through all three surfaces? Find electric flux due to Q through all these surfaces. What are the three surfaces of cylinder? One is cross section, another cross section, and third is nothing but a curvilinear surface. This one, curved surface. तो तीन सरफेस है, उनमें से हमें निकालना है about these three. What is the total electric flux? Total electric flux is Q by epsilon naught. That everybody knows. How can we find out the electric flux through this? How can we find out electric flux through one of the surfaces? This angle is theta. So what is electric flux through this? This particular case is similar to the case which we have done here. This is similar to that. Can you tell me what is theta in this? If you see, this is the triangle which we are getting. This is r, this is also r, this is theta. So theta is nothing but 45 degree and cos 45 degree is 1 by root 2. So in this case theta is this much. Can I use this formula now? Q by 2 epsilon naught. So phi through any of the surface, let us say this is number 1, this is number 2, this is curvilinear is number 3. 1, phi through 1 and 2 is going to be same, and that is going to be Q by 2 epsilon naught. 1 minus cos theta means this. So what is total is phi 1 plus phi 2 plus phi 3. Phi 1, phi 2 we have calculated. So through the curved now, if we want to find out, phi 3 will be equal to Q by epsilon naught minus double of this. So Q by epsilon naught into 1 minus 1 by root 2. So if you subtract it, eventually what you are going to get is nothing but Q by root 2 epsilon naught. Just check it out whether it is correct or not. This comes out to be Q by root 2 epsilon naught. That is through curve we have got this particular expression. So I think this is what something which is very important about electric flux. तो हमने ये पहले दो टॉपिक्स जो किए हैं, that is electric flux and Gauss law, and all these 50 topics which I am going to cover, don't miss these topics. इनमें एक दूसरे के साथ रिलेशन होगा, and end में I am going to cover the questions also. So the moment I am going to cover the questions, आपको पता लगना चाहिए कि हाँ ये क्वेश्चन उस कंसेप्ट के बेस पे आया था. So the moment this concept is clear to you, you can solve the questions also. I'll make sure that most important topics are covered in minimum possible time, because you know, if I give you 300 hours only for physics, you can do physics, that is not a problem, but we do not have 300 hours, because there is a physics, there is a math, there is a English, there is a so many other things, and you people are otherwise also preparing for other exams. So we should try to minimum cover the maximum important topics in the minimum time. That is a challenge. Challenge is not that I am to cover it. I mean, I may tell you that 200 hours of physics, 200 hours of maths, but we do not have that much of time. So most important topics, concept should be clear, and these all notes you can take, they are available on YourPedia Education platform. आप उनको डाउनलोड करके ये वीडियोस भी आप सुनना स्टार्ट करें, so that you revise this, and most important 50 topics are there for you. So my another advice is, listen to these topics within day or two, because later on these may be removed because they are the part of our paid registration model. But yes, you can watch within 2-3 days so that you revise it. All the very best, and keep watching all the topics.